This chapter is on solving equations and inequalities, and right now we are going to begin with the simplest of those situations, which is an equation where the variable is on a single side. It could be the left or right side, but it ultimately does not matter, it doesn't change what we do. Most of the time our variable will be x, and as you can see on these examples, we have the variable on the left. To solve an equation, we are basically going to reverse the order of operations. So if you remember from our last chapter, the order of operations is parentheses, exponents, multiply and divide, add and subtract. So PEMDAS is what most people learn. We use the abbreviation GEMDAS for grouping. And we want to remember that when we get to multiplication and division, if we only have those two things, we go left to right, no matter what order they're in. And addition and subtraction, again, left to right, no matter what order they're in, if that's all we have left. When we're solving equations, we should always simplify when possible. We want a reduced answer, the simplest possible answer. So for example, if you were to write down this, for whatever reason, you had decimals and you had 6.8 over 2.1, that's not going to be acceptable. I would actually expect you to divide that. You can go ahead and put it in your calculator and finish it off if you were to get something like that. And I would expect you to write down, in this case, 3.238, and then you have 091, whatever that happens to be. Now, that example, those decimals don't happen in the examples I have down there. But if it were to happen, simplest possible answer. Same goes if you had like 8 over 2. Like if you were to get that as an answer, obviously you should reduce that and simply write 4. So simplest answer. In order to solve, we're going to use inverse operations. That means we do whatever it takes to undo. So addition and subtraction are inverses of each other. They undo each other. So if I see a plus, I'm going to subtract to undo that. If I see a minus, I'm going to add in order to undo that. And the same is true with multiplication and division. Those are inverses. They undo each other. And of course, roots. So if I had like an exponent, then I could root that. So those are inverses of each other. So if we have a bunch of groups, we need to get that group alone first, which kind of flies in the face of everything we've done so far. We usually are just doing the grouping first, but in the case of equations, if there's a group, like an absolute value group, or we have a bunch of stuff in a square root, we are going to undo everything else except that group first. And I'll show you an example of that at the end of this lesson, because to challenge you, I'm sure you'll understand it once you see it. And of course, we need to remember our goal. The variable needs to be on one side. In these examples, it already is on one side, but that is not always going to be the case. So my examples down here are pretty straightforward. I have an equation. Now I was trying to get you in our last chapter to really distinguish between solving and simplifying. So all last chapter we had expressions and we were simplifying. Now we have equations and we're solving. So know the difference between those two things and don't arbitrarily start inserting equal signs everywhere. It confuses everyone. Don't do that if you're simplifying. Alright, so I see variables already on one side. I don't have any grouping. I see addition. I see a multiplication. And I have a number over here on the left. So what we're going to do is we take our order of operations and we reverse it. So we have our GEMDAS. And instead of going down this way, that would be to simplify. We are actually going to go up and we are going to reverse it, and that is how we solve. Reverse it. So I see a plus 5. I'm going to subtract 5. You don't have to write this minus 5 if you don't want to, but if it helps you, go ahead. Anything I don't deal with, I go ahead and copy down. So I didn't do anything with 3x, so I'll copy that down. And now I see 3 times x. That's what that means. So to undo multiplication, I'm going to divide. And I'm going to show division with a fraction bar. and I get x equals 3 divided 3 is 1. We should always be in the habit of checking our work, so I would put this 1 up here into this x and just make sure it actually works out. And 3 times 1 is 3, plus 5 is 8, so it does indeed check out. This is fine. In the interest of time, I'm not going to check them all, but you should. Just saying. Alright, over here, I have a bunch of things going on. If we can simplify stuff, we should. And I see a 5x and a 2x, and those are like terms. So I can add them, and if it's not written, like right here, I don't see anything in front of that 5, so I assume it means plus 5. So plus 5 plus 2x is 7x, and I didn't do anything with this minus 9, so I copy down the equals, and copy down the 17. Remember, copy down everything you don't use. Alright, now it looks similar to the other one. I reverse my order of operations. I do not want to undo this multiplication, right? Because I will first undo the subtraction. Remember, I'm reversing this. I'm going opposite of it because I'm undoing everything. So I add the 9. And I'll get 26. Copy down the 7x. I didn't use it. And to undo multiplication, I divide. Now, I could put 26 over 7, divide it in my calculator, and get a decimal, but I don't want to do that. I'm going to say x equals this exactly. And you'll see why I don't want to. Well, I guess I could put that up here. That'd be pretty easy. 26 over 7 times 7. The 7's cancel. Gives me 26, and 26 minus 9 is 17. So this checks out. Alright, let's go on then and see what we have. Here we have a bunch of examples. I'm going to work each one, but what I encourage you to do is pause the video, try it yourself, and then see if you did it correctly. For each of these, I'm actually, with the exception of the last one, going to break the rule I just said where we reverse the order of operations, and I'm going to explain why. I really, really hate fractions. If I can avoid them, I want to avoid them. And so I see in each of these questions, the first 3, I have lots of fractions. So I want to do a mathematical trick, and that is to clear the fractions. Now, if you find what I'm about to describe too much for you right now, then go ahead and not do this. It would change what you do, the order you do them. But I'm going to do this each time. Clear the fractions. Well, what do I mean? I'm going to determine a common denominator. And then I'm going to multiply everything by that. And the common denominator, remember, is a least common multiple. Alright, let's just put that into action. That's a lot of words, and seeing it is a lot better. So I look here. I have 2/3. I have 3 in the denominator. If it's not written, 5 over 1 and 7 over 1. So the common denominator of 3, 1, and 1 is simply 3. So I'm going to use brackets right here to indicate I'm multiplying everything. And I'm multiplying everything by 3. We're going to use the distributive property and multiply this 3 into everything on both sides. That's important. You can do the same thing to both sides of an equation. I guess I should have said that earlier, no matter what it is. So, when I multiply, I'm not going to show this on all of them, but I'll show it right here. I'm essentially saying 3 times 2/3. And do you see what happens? The 3's cancel, and I have 2 left. So that gives me 2x minus 3 times 5 is easy, that's 15, and then 7 times 3 is 21. Now I don't have fractions, and I'm really, really happy. And now it looks like the previous slide. So I'm going to add 15, and I get 36, divided by 2, and I get 18. So 18 is the final answer. Let's take a look at this next one. Now, if you don't like clearing the fractions, you could do it like normal. So in that case, I'd subtract 9. And I got to remember this is a negative, so this is negative 4/5 x. Now the x is either off to the side or in the numerator. It is not in the denominator, at least not in this case. We have a 4. Now, this means to divide by 5, and this means to multiply by 4. So I could undo this one by multiplying by the reciprocal. So I'm going to do that. That's a good trick. I just flip that around. And you see the 5's cancel, the 4's cancel, the 4's cancel here, and I get 5, and then everything canceled over here, x equals 5. And I'm sure you're thinking, gosh, oh, I made a mistake. It was a negative, right? So negative 5. Yep, that looks good. I'm sure you're thinking, gosh, that's way faster than over here. Yes, in these simple ones, doing the multiplying by the reciprocal of the fraction is faster in those cases. But look at this third case. Notice I have a fourth, a fifth, and a third. So I have a fourth, 3/5, and 2/3. That's a lot of fractions. I do not want to deal with all those fractions. I will likely make a mistake. So I think of the least common multiple of 4, 5, and 3. And the number I'm coming up with is actually, I think, 60. So I am going to multiply all of this by 60. Now, if you don't see the 60, you could write out the multiples of 4, the multiples of 5, the multiples of 3, and find the smallest one that they have in common. Maybe I'm wrong. Maybe it's not 60. But if you can't find it, you could simply do 4 times 5 times 3. That gives you a common denominator. It might not be the smallest one. And that is 60. So I'm going to multiply everything by 60. Now when I distribute to this first one, what's happening is 60 times a fourth. Well, cross cancel, and I get 15, don't I? So 15x right there. And then when I come over here, 60 divide 5. I don't even know if I know that one. Let me see. 60 divide 5 is 12. So what's going on is I have 60 times 3/5. Cross cancel. Get 12. And 12 times 3 is 36. So this is 36. No x though. And then minus. Do you see what I'm doing? 60 divide 3 is 20. And 20 times 2 is 40. And then 6 times 60 is 360. Combine like terms, I get negative 25 plus 36 equals 360. I'll subtract the 36. And 360 minus 36 is 324. And now divide both sides by negative 25. So 324 divided by 25 is x equal negative 12.96. Or, actually, you could just box that. Negative 324 over 25, it doesn't reduce. I would accept either of these answers. I actually like this one better. I like the fraction answer better. Alright. The last one actually is the easiest one, in my opinion. The variable is on the right, but it doesn't matter. So I have 15. Combined like terms, 2 minus 9x is negative 7x. And then I have a plus 1. Undo the plus 1 by subtracting, I get 14. And then I'll divide by negative 7 and get negative 2. Alright. Hopefully you understood all that. Let me just make sure I did everything. Nope. Didn't do everything. Let's do a few examples. And then I'm going to get to, I wanted to show you, well, what if I have a grouping, what I do then? Well, I do have a grouping down here, but that one's easy. Alright, so even though the variable's on one side, I do have multiple steps. So here I see I should distribute this 3. So I have 3x minus 12 minus 5x equals 18. Now, I'm just saying, if this say this had a square right there, then you could not distribute in. But luckily it doesn't. So now we have 3x minus 5x, that's negative 2x. And copy down everything I didn't use. Add the 12, that gives me 30. Divide by negative 2, gives me negative 15. So there's our answer. Now, when we distribute, we need to remember to carry the sign with the number. So I'm going to carry that negative right along. 6x, negative 8x, negative 36. You'd be surprised how many people forget when they distribute to get all the terms. Alright, 6 minus 2x is negative 2x, and copy down. Add the 36, that gives me 56. And divide by negative 2, that gives me negative 28. So you see I distributed, combined like terms, added the 36, brought down, divide by negative 2, and negative 28. I didn't have to write that I was adding the 36 or divided by negative 2, but if that helps you, go ahead. Alright, this last formal example that I wanted to do, a couple that involve grouping that is not simple like this. Alright, I see a distributive, so I definitely want to do that first. So that gives me 10 over, now I could reduce this, but I am not going to bother, 18x plus 5 over 12 equals 17 over 12. And now I will bother. So divide this by 2. And it just so happens that clearing the fractions will be more difficult in this case because I already have a common denominator right here. So I'm going to subtract the 5/12. I'll finish my work over here. I have 5/9 So I'm subtracting this thing. That gives me negative, well, nope, not negative. That gives me 12/12, which is simply 1. Now I'll multiply by the reciprocal of this, which is 9/5. So even though I do prefer clearing fractions, in this case it didn't work. Well, it would work, but it would actually be longer. I'm a big proponent of doing it the fastest and most efficient way. So in this case, not clearing was more efficient. Alright, hopefully you followed along with that. I do want to do some questions that involve some grouping. Let's just see if we can figure it out. So, obviously it said chapter 2. This is jumping way ahead, but I know you can understand what I'm saying, so we're going to go ahead and do it. So let's say there's a 3 right here. This root implies that we have a group. It doesn't imply it, it tells us. And our group is this stuff. We always get the grouping alone first. So I'm going to add this 5. Notice I cannot subtract this 4, and the reason why is it's inside of the root, so it's stuck in there until I deal with this root. And I couldn't do 4 minus 5. That wouldn't make any sense. That would be like saying I had square root 4 minus 5, and that equals what? Negative 1? Like what? We can't do that. Obviously, we'd do the square root, which is 2. And 2 minus 5 is negative 3. So, but that has nothing to do with this. So we add the 5, and we get 8. And then I copy down this root that I didn't use. And now the concept of solving equations is you do the inverses, the opposites, in order to undo everything. And the opposite of square rooting something is to actually square something. So I'll square both sides. This square undoes the square root, and that gives me x plus 4 This root and this square undo each other, and 8 squared is 64. Then I'll subtract the 4 and get 60. And we're good. The same is true if I had other grouping symbols, but let's just try one more with the root. The thing with other grouping, like absolute value and squares, is that there are little extra things that you need to do, and I think it'd just be confusing to talk about them right now. But square root certainly is something that we could follow along with. I'm just making up these numbers, so who knows what will happen. I have no idea. Let's say minus 11. And I don't know, what do we want over on the other side? Maybe a 7? Only because I see that 3 over there, want it to work somewhat nice. So I'm going to undo this minus 11 first. That gives me 18. So I added 11 to both sides. I copy all the rest of this down. So I have 3 root 2x plus 9. Now, to undo this times 3. See, I'm trying to get this square root stuff alone. So I'm going to divide both sides by 3. And that gives me root 2x plus 9 equals 18 divided 3 is 6. And then the way to undo a square root is to square. And the square root is undone by the square, so that leaves me with 2x plus 9 equal 36. Subtract the 9, and that gives me 27. And then I divide by 2, and see x is 27 over 2. Of course, we would want to check that. I'll just tell you, check. Actually, I didn't check many of these, did I? One more question, and then we will be done. And only because I feel like this last question made you think that clearing fractions isn't the most efficient thing to do, and, well, you're entitled to your wrong opinion, I suppose. So let's say I have something like this. What do I want? 1. Let's put a 1 right there. But it could be a fraction. Now, in order to do this, I would obviously have to combine the 3 4x and the 7 6x. The thing is they're in fractions, and I don't want to deal with that. So I'm going to clear out all the fractions. So I'm going to multiply by the least common denominator for 4, 2, and 6, which is 12. I multiply both sides by 12. 1 times 12 is 12. This 12 distributes right here. 12 divide 4 is 3. That leaves 3 times 3, which is 9x. Distribute over here. 12 divide 2 is 6. And 6 times 5 is 30. And then finally right here, 12 divided 6 is 2. That leaves times 7. So 14x. Now it's so much easier than if I were actually to just deal with all these fractions. Now I'll add 9 and 14. That gives me 23x. Subtract the 30. That gives me negative 18. And now I divide both sides by 23. And I get negative 18 over 23. All right. That concludes this lesson on one-sided equations.